now to prove. I don't like hammer away at too many proofs in this course. But this is like the central fact, and it brings in all the stuff we know. OK, so I'll start the proof. Suppose A transpose AX is 0. And I'm aiming to prove A transpose A is invertible. So what do I want to prove now? So I'm aiming to prove this fact. I'll use this, and I'm aiming to prove that this matrix is invertible. OK, so if I suppose A transpose AX is 0, then what conclusion do I want to reach? I'd like to know that X must be 0. I want to show X must be 0. To show now, to prove X must be the 0 vector. Is that right? That's what we worked in the previous chapter to understand. That a matrix was invertible when its null space is only the 0 vector. So that's what I want to show. How come, if A transpose AX is 0, how come X must be 0? What's going to be the reasoning? Actually, I have two ways to do it. Let me show you one way. This is, here, trick. Take the dot product of both sides with X. So I'll multiply both sides by X transpose. X transpose A transpose A, X equals 0. I shouldn't have written trick. That makes it sound like just a dumb idea. Brilliant idea, I should have put. OK. I'll just put idea. OK. Now, I got to that equation, X transpose A transpose A, X equals 0. And I'm hoping you can see the right way to look at that equation. What can I conclude from that equation? That if I have X transpose A, well, what is X transpose A transpose AX? Do you see what it's giving you? It's again going to be putting in parentheses. I'm looking at AX, and what am I seeing here? It's transpose. So I'm seeing here, this is AX transpose AX equaling 0. Now, if AX transpose AX, so like let's call it Y or something, if Y transpose Y is 0, what does that tell me? That the vector has to be 0, right? This is the length squared. That's the length of the vector AX squared. That's AX times AX. So I conclude that AX has to be 0. Well, I'm getting somewhere. Now that I know AX is 0, now I'm going to use my little hypothesis. Somewhere, every mathematician has to use the hypothesis, right? Now, if A has independent columns, and we're at the point where AX is 0, what does that tell us? That could be like a fill-in question on the final exam. If A has independent columns and if AX equals 0, then what? Please say it. X is 0. Right. Which was just what we wanted to prove.